We saw that a small section of wire can alter the space around it, provided there is flow of current. It depends on the amount of current, it depends on the length of the wire, it depends on how far the point is, and of course the angle. And we saw that the amount of force is given by dB formula and so on and so forth, and the direction, right hand rule. Now, of course, we will not have a small section of wire all the time. What we will have is a long length of wire, right? Of course, it will be crisscross and bent and all of that. But we'll start off with a very simple scenario. A wire which is of finite length, say length L, and we're looking at how it will affect a point P. Basically, how the magnetic field will change over there. That's what we're trying to learn. So our heading is expression for magnetic field strength by a long straight conducting current. I mean, long straight current conductor. So overview of the derivation. See, we know the idea of dB by dl. Now, if you think about it as per your right hand rule, right? What can we tell? Since the current is same and the same amount in terms of amount and direction and everything, right? If I take up any element, the same amount of current, say I, is flowing through it. But what will change? This is what you guys have to tell. But with different what? Again, what I'm trying to ask is, say this is DL, right? This is a wire, this is DL, this is DL. Between these two, what is same and what is different? We are trying to figure out how it affects the space of the point P. You guys need to answer this. Yeah. Okay. Let's see. This is your distance. This is your distance. Will the distance remain the same or different? They will vary. What else will vary? If this is the angle theta, this is theta 2, for example, theta 1 and theta 2. Will it be the same? No, it won't be the same. So go back to the formula dB. What is dB dependent on? dB is dependent on I. I though is not changing, right? This is constant. dl sine theta by r square. So this is constant, right? This is also constant, the small length dl. This varies and this also varies, how far it is. So all in all of this varies with different r and theta. And so basically we should be able to add all of them. How will we add all of them? Yes, with the help of integration. So in integration, what will change? Well, of course, the expression. That's pretty important. We need to handle the expression. And what else will change? The limits, mainly the limits. Okay, actually everything is main thing. Now the funda is, how will we integrate this? This has to be in terms of a single variable of integration. To make it simple, of course, we can do quite a few things. We can integrate with multiple varying variables. Single varying variable. Let me put it this way. Single varying variable. And with respect to that, the limits as well. So this is what we are trying to look at. Okay, so let me just do this. Now the derivation starts in this way. First, we are looking at a straight conductor. We're naming it as XY. And we have the current I flowing through it. We're considering a point P, which is A units away, right? OP is A unit. We're looking at R, position vector, to P, right? And we are relating the current element dl. Theta being our angle between R and dl. Now, let's write the obvious. So, as per the Biot-Savart's law. Hmm. The magnitude is dB and the element is dl. So we have dB is equal to I, it depends on the current, how long the wire is, the angle we are dealing with, and the distance. So when we remove the proportionality symbol, we get the constant mu naught by 4 pi. Okay, guys. Now the question is, how do we move forward? You know, it has to work out. End of it, we need to be able to add everything. So how will we do that? See, at point P, this happens. All the section of wire add up as they are pointing in same direction. As their dp is pointing in same direction. Their dp are pointing in the same direction. Do you guys agree? Right? If I use right hand rule, so my current is pointing this way, my thumb will be pointing that way, and my palm is facing the screen, or us basically, not screen. So when my fingers, it will be pointing towards us out of the screen. Okay, something like this. So when every element is pointing that way, we can add it up. We can add up the effect. But how much effect is what we have to try, what we have to figure out. At P, all the section of wire add up. The effect of the, actually the language is not right. Let me change that later. So let me give some space. Now the funda is here. We need to express all varying terms actually. Don't get confused with variables. In terms of constants. Okay, a constant and something, a single varying element. Now let's see what is convenient. So what is fixed over here? Current is fixed. The distance is fixed. What else is fixed? Is theta fixed? No. Is R fixed? No. So we will make use of the help of constant I and A. But in geometry, I will not matter, A matters, and the angle matters. So all of this integration has to do with the length and the angle and everything. So that is the funda. So how can I integrate? The best way to integrate is taking an angle which varies from one end to the other. So for example, this angle will vary from this end to the other end. So let's call this as phi 1, I guess. This is phi 2. And the common variable which will vary can be represented with phi. So we're going to express in terms of A and phi, because A is fixed and the phi is the element that will swipe from one end to another end. You can imagine a pen. It's swiping from this end to this end, and that's what we are trying to do. Okay, guys, it's like, think of this as a lighthouse. It's moving from here, swiping, and over there. I'm trying to show it with my stylus, but obviously it will not work. You guys can't see that. So in terms of what? A and phi. So let's see. This is constant, this is constant, this is constant. We need to express dl, sine theta, and r. So let's start with the easier one, sine theta. Sine theta is equal to sine of, again, we're trying to express in terms of phi. So this is a right angle triangle. So this will be 90 minus phi. So we can tell from figure. So this is nothing but cos of phi. So sine theta is cos phi. Next, right? We have an R. So let's look at it. R is hypotenuse, A is your adjacent to phi. So this will be what, guys? This is cos, and that is hypotenuse. This is okay. This is A by cos phi, which is A sec phi. Next, what else we have? We have dl. Dl varies. So dl is nothing but your length. So I have to take another element, say L, expressed in terms of the side of the triangle. So this entire length is L. So we are trying to relate L, A, and phi. So what can I use? L, A, and phi. So how to analyze this? L is an opposite side, A is the adjacent side. So we have to make use of what? Yes, we have to make use of tan. So tan theta is L by A. So A tan theta. But we want dl. Therefore, dl is equal to A secant square, sorry, not theta, phi d phi, right? Dl by d phi is this expression. So yeah, bit of rearranging and we have that. Therefore, finally we have on substituting above in dB, we have dB is equal to mu naught by 4 pi I A secant square phi d phi. This entire expression divided with A square secant square phi. And I'm missing sine theta, which is cos phi. Okay. So what happens? Quite a few things can get cancelled over here. So this set of element and this. Okay, agree? So what next? Let me express dB, which is equal to this set of constant. Current, in this case, it will be fixed. We'll left out with cos phi d phi divided by A. And now we have to look into limits. So what is the varying variable over here? Phi, right? Phi is varying. How will it vary from one end to another end? It varies from phi 1 to phi 2, right? So limits phi varies or is able to cover varies from phi 1 to phi 2. Therefore dB, actually B, which will be equal to integrating dB, right, will be equal to integrating phi 1 to phi 2, the expression mu naught by 4 pi A I cos phi d phi. Guys, remember this thing is constant. So mu naught 4 pi A I integration of cos phi and all of that is sine phi on applying the, oh yeah, sorry. This is negative angle, by the way. And that's positive. Do you guys agree? Right? So we have, because we can consider one of the angle, like in this case, it is clockwise as positive and this is negative. So we have minus sine minus phi 1. So minus of minus theta is because, see, for me, how I got to know I made a mistake over here is taking the limit, because we need to add up, they are not cancelling each other. They need to add up. That sense was there, and that's how I got to know I made a mistake, and it had to be so. Sorry, this is 2. This is 1 and this is 2. My bad, my bad. So post integration, we get this answer. As simple as that. Okay, guys. So we have to have angle measuring in this direction, right? If we consider this as positive, so phi1 is positive while phi2 is, which is measured in the opposite direction, it's negative. And so the limits, it's like adding from -3 to 10. So -3 to 10, if I integrate x square or something, or x to the power of 4, the result will vary. So that's your result. So basically, we have your answer to be the constant terms divided by a, that is the perpendicular distance. So it still depends on the distance. It still depends on the current and of course the angles. Indirectly talking about how long the wire is. Agree? Now, special case. What if it's infinitely long? What will happen to the angle? Think about it. If I make this as infinitely long, right? The wire that is, what will happen to the angle? How much should it open up? A lot, is it not? How much lot? Almost 90 degree. So phi1 or say upper limit will be equal to 90 and the lower limit will be equal to minus 90. In terms of value, it is 90 degree again. So we have P is equal to mu naught by 2 pi ai, because this term will be equal to 2. So all in all, we have this particular answer for this special case. Infinite long wire. Infinite long wire with point near the end. So basically the wire, the point is over here. So what is happening? The phi1 or phi2 in our case will be equal to 90 degree, while phi1 will be equal to 0 degree. So this will be what? This will be just P is equal to, again, I'm doing the math directly. So this is 1 plus 0. So this will be 4 pi a I. Infinite long wire with point along the perpendicular bisector. So basically in the middle. So if it's in the middle, these two angles have to be equal, right? So in the middle, this length will be equal to this length. This is common. How will that happen? We need to have, okay, let us write it off. So B is equal to mu naught by 4 pi A. This is dependent on current, and we have sine phi. Oh yeah, this will be same. Sine phi. These two angles will be same. That's what will be our funda. This is mu naught by 2 pi A I sine phi. Right? So infinitely long. Yeah, that's it. And they're infinitely long though. So what will happen? At the end of it, this is again 90. We'll end up with the same thing. So we'll end up with the same expression, to be honest. Actually, this case is not finite. Sorry, infinite case. This is finite. That's where I went wrong. Finite long wire, not infinite. So in that case, yes, it will vary. How? Let me show that. The formula can change. So we have a finite length L. Okay. And this is the scenario. So this is A, this entire length is say 2L or say L. So this is L by 2. That's your phi. And so we have sine phi from the diagram. Or we need sine phi actually. So opposite L by 2 by adjacent square root of, sorry, by hypotenuse, and that is equal to Square root of a square plus l square by 4, which I take the LCM, 2 will get cancelled. So basically this will be mu naught by 2 pi a I L by root of, again, simple maths, LCM will be 4a square plus l square. Simple maths, you guys should be able to do it. I'm just writing the final answer. Okay. So yeah, for infinite again we'll end up with the same answer, to be honest. So that is what I was wondering. Why is it coming to the same? It's infinite now. Infinite my middle is like, I thought it's a weird scenario, but this is finite. Now it makes sense. So finite long wire of length. In this case, we have taken it as L. Capital L. Okay. Okay, guys. Does it make sense? So that's that. Here the funda is this. This is what is important. And I have to change this language now. Let me see. Okay, yes. Better language, but the point is the same. So we have to express all the variables in terms of a and phi. Deciding this is the key. Everything else is simple maths and concepts. Nothing else. Literally, deciding this is what you guys have to learn. Right? So that's the important part. Everything else is, you just have to copy. That's it.